Hello, fellow Scratchers! Today I have something really special for you. Look at all these cats. There's so many that by the end you can't even see their faces. But what is nice is that they are ordered from back to front, giving you that feeling of a crowd of cats. Indeed, take away that ordering, and we are left with a complete jumble, a mess of cats. Hold on. There, phew. Add back the layered ordering and everything is good again. We know these cats are all standing one in front of the other. Here's another, less crowded, but far more dynamic scene. You'll see the characters walking behind the trees. But don't be fooled into thinking these trees are simply always in front of the other sprites, because watch as we drag this nano character in front of a tree. And then, yes, behind a tree. How cool is that? It looks so natural that you'd be forgiven for not even noticing what is happening. In simple terms, a sprite that is further down the screen is displayed in front of any sprite that's above them on the screen. This effect is applied to everything, even the trees. It can be moved around and then correctly reshuffle in front or behind the other sprites as needed. I'm sure we could have a lot of fun with this, and I bet just seeing this is triggering all sorts of the fun game ideas that you could be making with this, right? To be able to make this work, we need a lot of control over the layering of the Scratch sprites, more so than Scratch appears to easily provide us with. But thankfully, I have devised a very cunning technique that is both super fast and easy to use. Yes, it's so good, and I'm going to teach it to you today. And just in case you were wondering, here are a few other projects that make use of this technique. My initial depth sorting project, the Fibonacci sphere project, oh I love that one. And then there's my Don't Starve test project, similar to what we are creating today. But even projects like Apple make use of this technique to ensure all the sprites initialize in the right order before the game begins. So man, this is so useful. Have I sold this to you? I hope so. Yeah, let's get scratching. We can start with a fresh project. But to save you looking at this boring white background, let's fancy this one up a bit. Click on the stage and enter the backdrop editor. I'm going to choose one of the preset backgrounds. The one I have in mind is the simple stripes one here. I'll ungroup it and then fill in the two sections separately to give a very pleasant green grassy effect. There, that's better. And now we can proceed. So clicking back into Sprite 1, we need ourselves a few more cats. When green flag clicked, repeat 3. And create clone of myself. This will make 3 new cats for Scratchy to play with, but just to ensure they are spread around the screen when they appear, bring in a when I start as clone hat block, and pop in a go to random position. There, nice. Let's also size Scratchy up a bit. Use a set size block after the green flag and set size to 150. We can run the project now by clicking the green flag. So we have 4 cats, the original sprite and 3 clones. How can we tell which one is the original sprite? Just click on the sprite in the sprite palette down here, and Scratch will highlight them on the stage. There, that's the one. Okay, to help us talk about sprite ordering, I'm going to shuffle them into a line. So, in Scratch, to move a sprite in front or behind other sprites or their clones, all we have are these 2 blocks, the go to front to back layer, and the go forward, backwards, a number of layer blocks. I can tap the go forward 1 layer to shift the current sprite forward 1 layer, moving it in front of the sprite ahead of it, like so. So, what is the problem then? Well, although we can tell Scratch how far to move forwards or backwards, and can see the effect on the stage ourselves, we don't have any way in our code to know which sprites are in front of the others, or what layer they're on at all. No, we are rather in the dark, and this is unfortunate. We could really do with this information. Is there really no way to find this out? Well, maybe there is. Make a variable named order. Now it's very important you mark this for all sprites, okay? So we'll start by setting order to 1. Next up, we want a broadcast. And make a new broadcast message of order sprites. We can always be hopeful, right? Now, bring in a when I receive order sprites. This will trigger for sprite 1 and all its clones. So if we say and pop in the order variable. Then clicking on the top script here will make all 4 sprites say, well, 1, because that's what we set order to. So not useful thus far, but hang on there, and here's where things get interesting. Place a change order by 1 after the say block. Running the top script again, and suddenly each sprite is reporting its own number. Now perhaps you were already expecting this. After all, we know that these broadcast events do actually run one after the other. So the value of order now increases before the next cat gets to say its order value. We can tell which one ran first because it has the number 1. Yes, it was this one here, the one at the front of the other sprites. The next one is the one just behind. Interesting that the numbering is in order from front to back. Is that a coincidence, do you think? Well, easy to test. We just drag one of these cats in front of the others, and then run that top script again. Now, would you look at that? The one we just brought to the front is now reporting number 1. Indeed, each time we reorder these scripts and rerun the script, the order of these numbers always reflects the order of the sprites from front to back. Amazing! We have found a way to find out the order of the sprites with just using a broadcast and some variable, as long as it's for all sprites, as the value needs to be carried from one sprite to the next for this trick to work. So this is a good start. Now we need to know which sprite is supposed to be in front of another, so that we can shift them into the correct order once more. How do we know which should be in front of the other? Well, for now, we can use each sprite's Y position. Any sprite that is further down the screen should be moved in front of the sprites higher up the screen, just like they are right now. So stop right there. All we have so far is the order number of each sprite. How are we going to compare Y positions between clones and other sprites? That's a very good question. I'm glad you asked. We need more information than a simple old order variable can give us. But what can store more than a variable? It's time for an upgrade. Let's make a new list. Now, this is going to store the Y positions of the sprites, but in reality, it's storing the depths of the sprites, or how far into the screen they are. This is often referred to as a sprite's Z position, and since this is for sorting, we'll name the list Z order. It's important once more to make this for all sprites. Just like with the order variable, we need to reset the list before we broadcast each time. So delete all of Z order. Then, when each sprite receives the order event, we now add thing to Z order. But do it right at the top before we say anything. What we'll add to the list is the Y position of the sprite. For now, we'll replace this say order variable with a say length of Z order. Now be careful here, I'm going to delete the order variable altogether, which, if you watch this script, it removes any blocks that are using that variable. See? All cleaned up. So what will this script do differently than before? Click the top script to run it. Right! Obviously, the list has been filled with Y positions. That's new. But what isn't different is that each sprite is still saying their layer order, 1 through 4. How does this still happen without the order variable? Well, each cat is now reporting how many items there were in the Z order list when they ran their script. So obviously, the first cat has just one value, their own Y position, so it says 1. The second cat, though, can see the first cat's Y position plus its own, so they say 2. This continues for all sprites until the last cat can see all the Y positions and the list is full. Now at present, the list of Y positions is nicely ordered from lowest to highest numbers, but equally our sprites are ordered correctly from front to back. If I was to jiggle the sprites out of order on the stage and then run the top script once more, we can see not only are the cats out of order now, but so is the order of the Y positions in the Z order list. And therein lies a possible solution. If we can work out how to reorder the list from lowest to highest, maybe we can also reorder the sprites from back to front at the same time? Wouldn't that be a thing? So, who knows how we can sort a list of numbers in Scratch? Let's start with just 3 cats on the stage, with Y positions of 10, 20, and 30, respectively. Only, man, they are ordered back to front. We want the cat with the lowest Y position of 10 to be displayed in front of the pack. So bring in our Z order list. Let us simulate how the script will run. To make it easier, since the scripts run on the frontmost sprite first, I'll hide the back sprites from our diagram until they're needed. The first and topmost sprite has a Y of 30. All we do is add the number into our Z order list. Like so. Nothing more to do at this time, so the next sprite back gets to have a go at running some scripts too. This one has a Y of 20. Now, previously, we were just adding this to the list, like this. But now we are wanting to order this list from lowest to highest, so 20 should not be below 30. So instead, let's push it up to the row above. Better. And at the same time, and this is the fun bit, we do the same action with the second sprite on the stage, moving it forward by 1 layer. Wow, nice. Both the list and now the sprites are in order. Thus far, anyway. And now we can proceed on to sprite number 3. Here it is, just behind the other 2 sprites, with a Y of 10. Question is, does 10 belong at the bottom of the list? No siree. It's smaller than 30, so shuffle it upwards. And the sprite too. But look, it's also smaller than 20. So shuffle it up again, right to the top. So now we have moved the last sprite forward by 2 layers, not just 1. And the job is complete. All our sprites are in order. How awesome is that? Now, to code this, we just need to follow the same pattern. But remembering, it needs to run really quickly. We will make a few optimizations. Firstly, there's no need to move a sprite forward multiple times, when we can just wait until we know how many layers we need to move it, and then move it forwards multiple layers in one go. Secondly, we are going to turn the list upside down on its head. So rather than adding the items to the bottom of the list and scanning upwards, we will start looking to insert new rows at the top of the list and search downwards instead. This sounds more complicated, but it actually simplifies the scripts quite a bit. So do you want to join me and have a stab at putting this together in code? Oh boy, yeah! Well, we are certainly going to have to do some looping, so we'll need a custom block for the task. Make a new block, naming it order sprite by, with a numeric input of Z position, and then tick the run without screen refresh. This is a must, as it makes sure the whole script will finish running before the next sprite runs its script. Without this, the whole idea won't work, so do make sure to check it. Let's rearrange the code to use the new custom block. Move the scripts from the when I receive order sprites into the custom block, and replace them with a call to order sprite by. Pull the Y position out of here, and use it as an input to the custom block. Later on, we will want to experiment with other values in here, other than the Y position. So this is a nice easy way to make that possible. Now pop the actual Z position input variable into the add block in place of the old Y position. Cool, so apart from a rearrange, this should have made no difference to how our scripts run. We can quickly confirm this by moving a sprite and clicking the old topmost script again to run it. No difference? Good, we are ready to begin then. So yeah, this script here was good for testing, but we have bigger plans for it now. Move it out of the way. We want to code up the steps that a single sprite will take to order itself. Rather than imagining how this will look for the first and topmost sprite, let's instead assume we are one of the bottom sprites, and the Z order list is already full of values. So we have the Z order list, and we also have the sprite's Z position. Now we must look through the Z order list to find out where it belongs. make a new variable, simply naming it I. We'll use it to keep track of which item in the list we have looked at. It can be for this sprite only. Set it to 1, the first item in the Z order list. Now, to loop through, we'll actually use a repeat until block. The list is already ordered, with the largest numbers at the top and the smallest numbers lower down. So we are looping through until we find the first item less than our Z position variable. That will indicate where the new value belongs in the list to keep it ordered. So repeat until our Z position is greater than item I of the Z order list. That's the same as the item of list being less than Z position. I just flipped it. Then in the loop, just change I by 1 to keep us moving on to the next item until it's found. Now you may be crying, hold on! What if we reach the end of the list and we never find an item less than the Z position? Will this loop never end? Well, luckily, we can check this to confirm. When you ask for an item past the end of the list, Scratch will give you the empty value. And a nice property of the empty value is that every other value is counted as greater than it. So, this repeat loop will always end once it reaches the empty value. This was a clever optimization to avoid adding more code. But there are more things to consider. We haven't thought what should happen when two sprites have the same Z position. At present, by using a greater than here, any sprite at the same level as another will end up shuffling back and forward a layer rather than staying put. That will be quite ugly, so perhaps we want to use a greater than or equals here. Writing two comparisons means longer code, but luckily it just so happens that greater than and equals is the same as saying not less than. So we can replace this with not Z position is less than item I of Z order. That's right, it means just the same thing. So are you still with me? I hope so. We are almost there. We now need to insert into the Z order list. The value, of course, is the Z position input variable. But where in the list do we insert? Well, wherever the I variable stopped. Phew! Oh my goodness, what a ride! That felt more complex than it looked. Something to really get your head around, I think. Before we finish it off, though, let's give it a quick test. Scroll up to the top scripts. Although we've not done any sprite ordering, we should have at least managed to sort our Z order list. Clicking the script now. Hey, would you look at that? It has worked! The list values are now sorted from highest at the top to lowest at the bottom. That's really satisfying, and a trick that not many scratchers can say they've accomplished. So if you got this far, then you are doing extremely well. Well done! You have successfully coded Insertion sort. All that leaves us with is a job of shifting the sprites themselves forward on the stage to match how we inserted the values into this list. We start with a go forward one layer block. So the distance into the list that we inserted is given by this I variable. But if you think about it, when I is just 1, we are actually saying we are already at the right layer and don't need to move forwards. So, rather than going forwards by I, we must go forward by I minus 1 instead. Yeah, that seems about right. I'm thinking we can test it again. Scrolling back up and click the top script to run it. Drum roll, please! Pow! Would you look at that? The sprites just instantly snapped into the correct order. Just like that. I can't tell you how excited I was the first time I got this trick working. It's really quite something. But we should test this some more. Now, I should have done this a while ago. I'm going to attach a when space key pressed to the top script, so I don't have to keep clicking it. Let me shuffle these up a bit. Are you ready? Press the space bar. And wham! They are sorted from back to front once more. Superb. Again. Oh, this is too fun. No matter where they are, this just works. We need to push this test a bit harder. Let's up the clones to 200. This will be crazy. Now, how long do you think it will take to sort all these sprites? 10 seconds? 5 seconds? 1 second? Pressing space now. Click. Wow, they didn't take any time at all. And we have perfect results. It's a beautiful crowd of scratch cats. I'm going to just drag a few of these back out of order just to confuse it. Space key. Oh gosh, so quick! And all the cats accounted for. Splendid. So the difficult job is most certainly done. The next thing to consider is how to use these scripts in our projects. We may want to order our sprites just once when the game begins. Our scripts would work great for this, but sometimes our sprites move around layers during gameplay, and in this case we might require the ordering to occur continuously. Let's experiment with that. We are left with just these few scripts then, and only these two on the right are the important sorting scripts. These scripts will need copying to every other sprite that we want to include in our ordering. That often means every single sprite in the project, in fact. But luckily, it really is just these two scripts, so not a big deal. That leaves this script, the one that triggers the sprite ordering. As such, it doesn't want duplicating into every sprite. In fact, we often only want this in one place. To make that clear, I'm going to move mine into the stage sprite. To complete the move, delete the script from Sprite 1. So now we can click into the stage, and let's switch this around to trigger off a forever loop. When green flag clicked, loop forever, and we delete all from our Z order list and broadcast order sprites. And that's it. This will keep everything ordered for as long as the project is running. Now watch this. If we run the project with the green flag, do you see what's changed? Previously, these new scratch cats were appearing layered randomly all over each other, but now they are cloning and appearing depth sorted right from the start. That's crazy cool. I think we can have even more fun with this by making the sprites draggable. Look under the sensing category for the set drag mode to draggable block. We can pop one right at the top under the green flag. This will allow us to drag the sprites around on the stage, even in full screen mode. Nice. Run the project. Let me grab a cat and slowly drag them around. Now that's something new. Do you see what's happening here? As I drag the sprite back and forth, all the sprites are switching order to ensure the cat is layered correctly, and it's happening continuously, all the time, and it's lightning fast. Surely impressive that this works with so many clones involved, but it's also a little bit hard to see clearly what's going on. Cutting that back down to 10 cats. And now as I drag this cat around, you can clearly see the reordering in action. Yeah, it just works. Before we continue, we should just speed up the initial cloning of the cats. Make a new block, naming it clone, ticking the run without screen refresh. Move the cloning repeat loop in there. Great. And make use of the new clone under the green flag. Just test that a few times. Great. That starts up much snappier. Now, with the ordering taking care of itself, I really want to make this project a little bit more fun. Let's add some motion. There's nothing new or complex here. Under the when I start as a clone, drop in a forever loop. Oh, but before we move anywhere, we just need to point in a random direction. I'll choose a random value between -180 and 180. That's any direction in a full circle. Then, in the loop, just move forward by 2 steps. We run the project. Oh, good grief! What a mess! Not quite what I intended. Let's tidy this up. Firstly, if on the edge, bounce. We need to keep the cats on the stage. And secondly, we need to keep those cats upright. Set their rotation mode to left-right. Cool. Run the project again. There, that's better. They're doing the cat shuffle. And the important thing is, They are keeping perfectly ordered from back to front with no extra work. Gotta be pleased with how easily this is working for us now. I know I am. Next up, I want to show you how to work with other costumes and sprites. We'll need a little bit more room on the stage first, so reduce Scratch Cat to a size of just 60% now. Good. Start by duplicating this sprite for ease. That way, we have those two ordering scripts for free. Click into the costume editor, and I'm going to choose a new costume from the library. There's a nice tree in here somewhere. We don't need these other costumes, so I'll clear those away. There, that's not a bad size on the stage for a tree, so I'll leave it be. Now, one thought I have. Trees don't tend to walk about. So perhaps we can remove this forever loop from the tree sprite. Okay, everything else can stay the same. All we have are the setup scripts and the two sprite ordering scripts. So simple. So let's try this out. Right. This is looking almost right. I can see the reordering happening, and yet there appears to be errors. Look here, if I grab this Scratch Cat and then move them in front of one of the trees, do you see the tree is popping in front of the cat before it should? How can I tell? Well, it's Scratchy's feet. As long as Scratchy's feet are below the trunk, Scratchy should be in front of the tree. But as soon as the trunk is lower, the tree should be in front. But this is not the case. And the reason this is an issue is that all our ordering has been based on each sprite's Y position, which is generally the centre of a sprite's costume. We need to move Scratch Cat up so that his feet are level with the centre mark of the costume canvas. Now click into the tree sprite and do the same with the tree costume, making the bottom of the tree trunk level with the centre mark of the canvas. Great, now we can run the project again. And does this look better? Oh yes, much better. Let's add a few more cats. If you go down in the woods today, you're sure of a big surprise. Yes, indeed. For every scratcher that ever there was is mingling there for certain because, well, Griffpatch said so. I love playing with this, but let's try less cats and more trees. Oh gosh, that's quite scary. Who knows what they are up to in there? The upshot of this is that you really should try anything and everything now because the fun is quite literally endless. I am going to add a little chicken costume to the Scratch Cat sprite. Making sure to keep their feet on the middle point of the canvas course, and then clone them in the scripts by duplicating the change costume loop. I want loads of chicks. Oh yeah. Oh, would you look at this? It's too cute! Imagine the game you could make out of this. One thing I'd like to change is that they all appear to be moving up and down the screen faster than left and right. This is simply because our brains see perspective and think the ground is sloping away from us, and so up and down movement is perceived as faster even though it's the same speed really. Let's change the when I start as clone script. The point in direction, change it to 45 to 135. That's diagonal-ish to the right. But then, if a random number between 1 and 2 ends up to be 1, then we'll flip the direction to the left using a turn by 180 degrees. Run the project again. Yeah, I like that. Less crazy up and down movement. So, how many of you spotted the odd chick out? Can you see them? Yeah, there they are, all alone and not moving anywhere. That's just because we're only moving the clones, not the original sprite. I feel sorry for it. Let's fix that. In the when flag clicked script, drop in a show just before we clone the sprites. And then a hide just afterwards. Okay, are they gone? Yeah, of course they are. So play with this. There's a whole bunch of fun ahead of you, and you simply must post your creations to the studio for this tutorial linked under the video because I can't wait to see them. We are almost done here today, but before we end, I just want to cover one more concept that will be very handy in projects using these ordering scripts. and that is what to do with sprites that you want to appear in front of everything on the stage, or that have a fixed layering. This is super easy. So for example, I can make a new sprite and I'll design a quick menu button. And behold, it does in fact stay right in front of everything else. That is, until you move one of the reordered sprites in front of it, and then it all goes a bit to pot. But fear not. All we need to do is take the two ordering scripts, the order sprites by custom block, drag it into the new sprite, and the when I receive order sprite script, drop that in too. Now it has already started ordering, but if we go into the button sprite scripts, what I want to do is bring this button in front of everything else. So we aren't going to order by the Y position this time. You'll see the sprite has already leapt into the front, but to be more specific, we can add a number in here. Remembering lower numbers bring sprites further forward. So stuff in something like -1000. That will bring the button right to the front of all the other sprites. And it's useful to note that +1000 has the opposite effect of sending the sprite behind all the other sprites, right to the very back. We can add any number of these kinds of sprites. Here's another. And note, while they both have the same Z position number of -1000, whichever is left in front remains in front, like it would in normal Scratch coding. But if we want to force one in front of the other, just change one's number to, say, -1001. That forces the button in front of the -1000 button, and so on. In this way, you could assign each of your sprites its own number, and then use this order broadcast to start them up in exactly the order you want them, every time. Yeah, these simple ordering scripts solve so many problems and open up so many exciting opportunities for our Scratch projects. What are you going to make with this? Let me know in the comments under the video. Well, I do hope you've enjoyed this video. Smash the like button to let me know, and don't forget to subscribe to the channel so that you don't miss any future exciting episodes. If you want to support this channel further, then you can join the Griffpatch channel membership to unlock those cool channel emoji, get priority replies in the comments, early access to videos, and if you are an educator or parent, you may like to go to the next level and join my inner circle, where you even get the Scratch projects themselves. So until next time, have a great week ahead, and Scratch on, guys.